Hey Thinksters, welcome to this video about tuples, and it's not just any video, it's the ultimate guide to tuples in Python. So today we will learn everything about tuples and named tuples too. So what have I prepared for you? First, a quick introduction about tuples in general, a bit of theory, then we will have a look at the syntax, compare tuples to other built-in data types of Python, look at the operations you can execute on tuples. We will talk about packing and unpacking of tuples, named tuples, and a summary. Okay, so let's just dive into it. So as I already mentioned, tuples are a built-in data type in Python, and there are other built-in data types. For example, lists and dictionaries and sets. We already have articles and videos about these, so make sure you check them out on the blog and on the YouTube channel. Then tuples are sequence types. What does that mean? A sequence type basically means that you can iterate over this container of data. You can access the elements inside by index, and you can slice them. That's also true for tuples, so that's why they are called sequence types. Then a very important thing about tuples is that they're immutable, so you can't change them. Another example of an immutable data type in Python are strings. If you have a string and you modify it, maybe you call upper on the string, so you want to convert all the characters, all the letters in the string to their uppercase, then a new string will be created. It's not the same instance of string as before. And the same is true for tuples. You can't just assign a value to an entry in the tuple that will return an error. And so if you want to modify a tuple, you have to create a new tuple and you have to copy the old values and put in a new value where you want to update the value. But we will see it in detail later. As I already mentioned, indexing and the position of an element is important in a tuple, because, for example, if you have a tuple which represents a point and in 3D space, then the first entry of your tuple is the x coordinate, the second one is the y coordinate, and the third one is the z coordinate. And if you put your z value in the first place, it's messed up when you instantiate the tuple, I mean. So the position of the value defines its meaning in the tuple, in the normal tuple. So basically you can think of tuples as data records. It's just like a read-only list, but it's not a very good comparison. It's better to think of them as data records. So let's have a look at the syntax. How do you implement them in Python? Here, this T1 is a tuple, and we create it using parentheses, and we have 3 values in the tuple. But the parenthesis is not required, actually. We have the possibility to create a tuple like this, like T2, just values separated by commas. And here's another important characteristic of tuples. They are not homogeneous, because you can put values of different data types in the tuple. In a string you only have characters, you can't have integers in a string. But in a tuple you can have integers, strings, lists, whatever. So it's not homogeneous. And here is a tuple which contains two empty tuples. Yeah, if you have no values inside the parentheses, this is an empty tuple. You can also create a tuple with only one value. Then you will need the value and a comma, or value, comma, and parentheses. Okay. And here are some more real-world related examples. The point in 2D space, for example, or person data records. And another important thing to mention about tuples is when you use them to call a function in a function call. Like in this case, we have a function which, it expects a tuple, or it could be a list too, but say we want to pass a tuple to it, and it returns the first entry of the tuple. So if we call the function like this without putting the parentheses around the tuple, basically when we create a tuple, it's possible to do it like that. We saw it here, for example. But when you call the function, you have to put the parentheses around the tuple values, because if not, Python will think that you are trying to pass 3 arguments to this function in the call, but it expects only 1, so it will throw an error. So here's the thing to remember: when you call a function and you want to pass a tuple as argument in the function call, you have to put parentheses around the values. And if we compare tuples to lists, for example, in Python, they are both containers. A container in Python is defined as an object which implements the dunder contains method. So you can call element in container with this container, with this object. Then, as I already mentioned, they are ordered. Tuples are ordered, so a set is not ordered. For example, you can't say at index 0 I have a certain value. It can be a different one each time, because sets are not ordered. Lists and tuples are ordered. They are both heterogeneous, so not homogeneous, like strings. I mentioned it before. They are both iterable. You know it, I guess. You can, for example, use them in a for loop for each element in the tuple. You can iterate over them. That's why they are iterable. Or more explicitly, they implement certain methods like the iter method, dunder iter. Indexable, yes, you can access the elements by index, and the tuples are immutable. And here, that's interesting now to compare a tuple with a list. A list is mutable. Yeah, you can say my list and then index 2 equals something. And you can assign the new value to this index position. But in a tuple, you will get an error because it's immutable. You can't change the tuple. That means also that the length of a tuple is fixed and its order is fixed. But in a list, the length and the order of the elements can change. Okay, so what can we do with a tuple? I already mentioned some of the operations. Since it's a container, we can do the x in tuple. So x is an element, for example, an integer, and we want to check if the integer is contained in tuple s. Then we write x in s or x not in s. That's possible because tuples are containers. They implement the dunder contains method. And then we can use the plus to concatenate tuples. This will create a new tuple which contains the values of s and the values of t. We can multiply a tuple with an integer, so s times n or n times s, where n is an integer and s is a tuple. Then we get a new tuple which contains the values of s repeated n times. So if s contains 1, 2, 3 and we multiply it with 2, we get a new tuple containing 1, 2, 3, 1, 2, 3. Okay. Then we have indexing and slicing. You can access an element of a tuple by its index, or you can cut out a subtuple using slicing. And then we also can apply the len method to get the length, or min-max to get the minimal or maximum value from a tuple. And we can count the occurrences of a certain element in the tuple using the count method on the tuple. Okay, so that was quite a lot of theory. Let's see it in practice.